Have you ever wondered what the universe is made of, how gravity works, why time moves forward? These are big questions that have puzzled scientists for centuries. Physics has given us a pretty good understanding of the universe. We know about atoms and the particles inside them. We have equations that describe gravity and light. But some things don't quite fit. This is where string theory comes in. Imagine trying to understand a beautiful symphony while only hearing a few notes. That's what it's like trying to understand the universe with our current physics. String theory aims to be the full symphony, explaining everything from the smallest particles to the largest black holes. It's a grand idea, a quest to find the universe's secret code. This code, according to string theory, isn't written with particles but with tiny, vibrating strings. Think of a guitar string. Pluck it one way, you get a certain note. Pluck it another way, you get a different note. In string theory, these strings are incredibly small, much smaller than even atoms. How these strings vibrate determines what kind of particle we see. One vibration might be an electron, another a quark, and yet another the force carrier of gravity. It's like the universe is a giant orchestra, and the music it plays is made by the vibrations of these tiny strings. For centuries, we thought atoms were the smallest things in the universe. Then we discovered even smaller particles inside them, protons, neutrons, electrons, but string theory takes us even further, suggesting that these particles are not the end of the story. Imagine zooming in on an atom, so close that the protons and neutrons look like giant planets. Keep zooming, past the quarks that make up those particles. String theory says that if we could go even smaller, we'd find something amazing, tiny vibrating loops of energy. These are the strings. These strings are so small that if an atom were the size of our solar system, a string would be about as big as a tree. It's hard to even imagine something so tiny, but just like the strings on a cello create different sounds depending on how they vibrate, these tiny strings create different particles depending on their vibrations. This is a radical idea, but it's also incredibly elegant. Instead of a universe made of a jumbled mess of different particles, string theory proposes a simple unified picture. Everything is made of strings. String theory is full of surprises. One of the most mind-bending is the idea that our universe might have more dimensions than we can see. We experience the world in 3 dimensions of space, up, down, left, right, forward, back, and 1 dimension of time. But string theory suggests there might be extra hidden dimensions curled up within the fabric of space itself. Think of a garden hose stretched across a canyon. From a distance, it looks like a one-dimensional line, but up close you see it has a second dimension, curled up in a circle. String theory suggests that our universe might be similar, with extra dimensions curled up so small that we can't perceive them directly. These extra dimensions might seem like science fiction, but they are a crucial part of string theory. They help explain how gravity works and why the universe is the way it is. It's like discovering hidden rooms in a house you thought you knew well. The idea of extra dimensions is still being explored, but it's one of the most exciting aspects of string theory. It suggests that our universe might be a much stranger and more wonderful place than we ever imagined. String theory is like a puzzle with some pieces still missing. It's a powerful idea with the potential to revolutionize our understanding of the universe. But it's also a work in progress. Scientists are still working on the mathematics of string theory and trying to find ways to test its predictions. One of the challenges is that string theory requires a lot of complex math. It's not something you can easily explain on the back of a napkin. Another challenge is that the strings are so small, they are far beyond our current ability to observe directly. Despite these challenges, physicists are drawn to string theory for its elegance and its potential to answer some of the biggest questions in physics. It could unlock the secrets of black holes, explain the very beginning of the universe, and even lead to new technologies we can't even imagine today. String theory might sound like science fiction, but it's real science, pushing the boundaries of our knowledge and inspiring us to see the universe in a whole new light. It's a journey of discovery that's just beginning.